Hello, we are here for one more lesson of this T-Flex Cam training course, and the topic for today will be the turning machining, in this particular case the part 2 of this topic. To remember, uh, in our part 1 we've seen some of the turning modes that were at the time finish turning, rough turning, threading and actual drilling, and today we are going to see the pocket, the, the grooving and the cutoff. For that I have a couple of files to show you the main examples, and I have still the same file I've used in the part 1 to show you the cutoff, and the cutoff will require a path. So draw, and in this particular case path, I will create one here, and that's it. And the cutoff, it's a very simple toolpath, because the purpose is to divide or to split the final part from the block that was started to make the part. So CNC, turning, cutoff, and then we need to choose the path. So this path here. I will choose one tool that I have here, the cut, and cut it. These are basic parameters, feed rates, rapid and work feed rates, coolers, spindles. I will leave all of these with 0, except the retreat height. So 0, 0 also, and 0. And I can put the tool on the left or on the right. Let us say OK and do a machining simulation to see if all is correct. OK, perfect. OK, very good. This is cutoff. Then we go to the pocket. In the pocket, I have a couple of drawings. We could still use the pocket to make this kind of contour. Okay, this is a little crowded with paths and lines, so I've decided to use some examples that we have also on the standard installation to show you on a clear drawing. So I have this example. And in here, we need the edge patterns. So turning, and in this particular case, pocket, we have 3 types. The first one is a zigzag pocket. So just choosing first the edge that defines the part, and then a new edge that defines the stock. This is very basic. Now choose one tool that I had prepared, which we can see it's a very standard round tool. One other important topic is this box here that defines the direction, okay, of the tool. So it is important for each type and the position of your tool and of your part. So in this particular case it is correct. Again, standard parameters, so feed rates. The pull out, it is to this direction. I want this pull out, let us say 100. Stock removal, we can say, for example, 5 mil, and calculate, and it will do something like this. So this is a zigzag, which for sure we can edit also. Let us give it a little shorter toolpath, so 2, and that's it. Okay, very standard. Let us do a simulation. So play. Very easy. So okay, done. What can we do here more? We have this turning direction that I'm not sure. Okay, what in this particular case will do, no effect. Okay. I will clean this and I will use now another type of pocket, in this particular case the pocket special, which is a little different, and for this particular case it will require a path, so I need to make a path on the part. So let us do a path, and I need to make one more to define the stock line. Okay, so CNC turning pocket special. So this one and this one, I will use the same tool. Feed rates, I will say the allowance as being 0, and let us calculate and see what happens. So I have a couple of parameters that are not correct, and in this particular case are these under travels and the over travel also 0, not very important. So stock 10, okay, it is perfect, and let us simulate this also. So very easy. And finish path, it is okay. It is important to understand that this difference that we see in here has to do, if we look on the tool, you see that the contact, the control point is in the middle of the tool, so that difference is the radius of the tool. Okay, if we say this point here, so the tool path on the particular case that we are using will, because we are using 0, this particular tool will be different in terms of the calculation. Now we have one final type of toolpath for the pocket, the spiral one, just speeding this a little. This in particular will require also two edge patterns that are here, and it is calculated, it's very straightforward as the others. So a couple of paths, let us say a little less, and also let us simulate it under here, but it is basically the same thing as the other tool paths. The only difference is this behavior in terms of the gradual approximation of the contour of the part. So it is basically the big difference. So it is also a quite interesting way and very used way to make the milling of pockets. So one last pass, and final one. Okay, perfect. So this closes the topic of pocket turning machining. Now we have the final types, the grooving. I have a couple of files also for the grooving. They are more or less the same. So grooving, and if you go to CNC turning, and we have a lot of grooving tool types. They are quite similar. This depends a little of the type of groove that we have. So we may have this cut through groove or a rounding one, and we can have also these kinds of grooves with chamfers or with roundings on top. So let us see first this one. So in here we need to have a path, which we have already done, and we should have another one that defines the stock of the groove. So this one here. I will say I'm not sure. I will use this one here. I'm not sure of the size, so but let us use it. And I can set a couple of parameters about the start on X or Z, and the returns and the offset value and the directions. I can use a couple of directions. I can set also the stock removal. So let us say 1, okay, on the left, and okay. I can set this kind of thing. Let us see if all it is correct or not. Okay, in this particular case it is wrong. I'm using a wrong tool. It's not perfectly defined, okay? We can try to edit this. Let us change in this particular case only the Z direction and try to fix this. So let us say, I'm not sure of the size, but let us say 20, a little more, 50. And in this 50 also, and I will use all of these values to 50. It should be okay. And even so, they are not correct in this position here. The offset value, I would say 1. Okay, and now they should be okay. 50 probably is too much. I would say around 20. I'm doing this. I should know the values, but my worry about this toolpath was basically show you how to do it, not losing too much time. So my apologies, but okay. It is again not correct because it is crashing into the part, but it will show you the move, which was my goal on this. We have also in grooving the rounding one, which it is not the case in this particular case. But let us try to use this to act as example. In this particular case, we just need to give it a point like this. We can define a tool. Again, we need also to have one tool. Parameters again, and now groove parameters. Okay, we need to supply the width of this. I'm not sure the width. I would say a little bigger, say 15. The depth I would say 10. No angle, and I can define also if it is an external groove or an internal groove, okay, and on diameter or on the face, and I can define the radius in these points. So if I say, I'm not sure about that radius, but if I say that this is radius 1 and on the other side it's also radius 1, and in the end I have no radius, let us see what it does. And as you can see, it will do something. Let us try to simulate it. again, we should have these prepared and know perfectly what we are doing. Okay, you see again, it has done some crashing, but I'm using a little random information about the tool and the groove itself. I have one more with roundings, which basically reflects that tool. Turning, again, grooving. So I can use this grooving with roundings or with chamfers. It is basically the same. Let us try in this one with roundings. So again, as you can see, it is the same. I will use now this pocket. As you can see, I have a couple of information around here about the wides and what it is, and about the radius. I would say this is radius 1, and this is radius 2 and 3. I'm not sure, but let us assume that it is correct. Something like this will happen, and it is basically what we want. We can do a quick simulation also. Too big tool, okay, and that is the problem. This is the problem of having 2D toolpaths, because we need to know exactly this kind of information to avoid having problems. Finally, we have under grooving, we have this grooving in depth, or when you have a slope. Again, basically it is the same, because we need to give it again a point. We need to define a tool. It is also the same information, and then we have this information as we had on the other types about the definition of the pocket, which I did not knew what it was before, and I should knew it. Probably 8. Let us see. We can have an angle or not. Let us say 30 degrees. Wide increase, okay, on the emitter, and let us assume that something will happen. I'm not sure what, but something will happen. So this kind of toolpath. These are the types of tools we have for the turning. Again, you should have a preparation under these groovings about what you have, and it is good to have this dimension, okay, to know exactly, okay, 14, to know exactly what are the dimensions of the groove. But my intention in these videos and in these examples was to show you the options that we have to create these kinds of toolpaths, and how to move with them. So even on the tool side, I did not prepare specific tools which we should have, because the size of the tool, it is very important to avoid this kind of problems. And as I said in other videos, we are dealing with 2D toolpaths, so there is no analysis of the system if he's entering in the part or not. So it's the user that has to be careful on this and to confirm that everything it is correct. Anyway, I hope all of these examples were easy and clear. If there is anything else that you need explanation, or if you have any particular case which requires our attention, please contact us. We are here for you and we will explain everything according to everyone's needs.